Okay, folks, welcome to the magical world of meta-analysis. Did you know there are more than 20 types of it? Yep, 20. It's like the Pokemon of research. Gotta catch them all. If you ever thought stats were boring, hold on to your coffee. This is gonna get wild. So let's say we wanna study heart disease. We dive into the research ocean and splash. We find a bunch of studies swimming around like confused goldfish, different sizes, different methods, total chaos. But hey, we're meta-analysts. We love chaos. We quantify chaos. 10 studies, 10. Each one says something slightly different. It's like 10 friends trying to describe the same date night. It was romantic, it was awkward, or something else. There was pizza. Who do you trust? Easy. You meta-analyze them all. We threw them all in our scientific blender. Add some statistics, shake it up, and boom! Out comes one big juicy result. The ultimate study of studies. It's like the Avengers, but for something like data. To cook a perfect meta-analysis, you need your ingredients. Effect size, weighting, model choices, force plot, heterogeneity, meta-regression, publication bias, subgroup analysis, and sensitivity analysis. Yep, it's a long grocery list, but don't worry, we'll taste test each one. Let's talk effect size, the superstar of meta-analysis. It's a fancy number that tells us how strong an effect is. We've got a squad of them. OR or odds ratio, RR or risk ratio, HR or hazard ratio, SMD or standardized mean difference. Each one measures the same thing, just with a different attitude. Now the first plot. This is where numbers become art. Blue rectangles, studies doing their thing. Purple diamond, the big meta conclusion or pooled estimate. Purple line, where the truths probably hang out. And that black line, that's heterogeneity. The messy cousin we all have at family dinners. The cleaner first plot is, the happier we are. Heterogeneity, the word sounds scary, but it's basically how much your studies disagree, like a group chat where no one agrees on where to eat. We use three tools here. Q-test. Check if the chaos is random. I2 tells us how much chaos there is. 0 to 40% is cool, chill, low, and greater than 75% is high, drama, so bad. Tau2 measures how wildly studies are running around. Imagine it has a zoo of beetles, still bugs, but wow, they are different. So, which model do we pick? If studies are pretty similar, go fixed effect. Calm, centered, one truth. If they're all over the place, go random effects. Wild ride, lots of variation. In other words, fixed is like one singer singing perfectly in tune. Random is like a rock band. Loud, messy, but still somehow makes sense. Now, we give each study a weight. Bigger studies get more weight, a smaller one less. Sorry, tiny studies, it's like a talent show. The louder one gets the mic. Ow, look at that puppy! So cute! Oh, okay, focus. Back to the math before the dog steals the show. Next up, publication bias. It's when only studies with shiny, positive results get published. Science's version of Instagram filters. We detected it using funnel plots, our little detective tool. Eagers test under parametric situation and Beck's test under non-parametric situation. The science police. If we found bias, we fix it with the trim and fill method, basically photoshopping your data back to reality. Now, let's test how sensitive our results are. We remove one study at a time, kinda like Jenga. If it still stands, we are good. If it collapses, oh, one of those studies was holding the tower. Subgroup time. We split the studies into mini groups, like men versus women, or Europe versus Asia, or Team Coffee versus Team Tea. Why? To see where the differences hide. It's like gossiping about data. Oh, this effect only happens in young people. Meta-regression equal data therapy session. We sit our variable down and ask, so what's really causing the chaos here? Maybe it's the sample size, or the year, or the study design. Whatever it is, meta-regression helps us find the troublemaker. Finally, the cumulative meta-analysis. We line up studies one by one and watch how evidence grew over time. It's like building a Lego tower of knowledge. And by the end, bam! You can see how science evolves step by step. Meta-analysis turning research confusion into clarity, with a little bit of chaos magic. Alright, buckle up. Did you think there was just one kind of meta-analysis? No way. It's a whole buffet. We can categorize them by the statistical model, a study scope, data type, study design, or even by their special goals. Basically, meta-analysis is like pizza. It comes in many flavors, but they're all delicious and slightly confusing. Now, let's peek into the model zone. Three big players rule the field. Fixed effect, when studies are peaceful and in harmony, assumes one true effect for everyone. Random effects, when studies argue a leader, accepts that everyone's a leader different and finds an average. Bayesian meta-analysis, the mysterious, flexible wizard, uses priors and beliefs to deal with small or complex data. So yeah, fixed is the perfectionist, random is the realist, and Bayesian is the philosopher. Data comes in all shapes and moods, and data analysis adapt like chameleons. Pairwise meta-analysis, the classical duel. Two treatments, one winner. Network meta-analysis, the drama queen, compares multiple treatments, even indirectly. Individual participant data meta-analysis, full-on data geek mode, raw data max accuracy. Aggregate data meta-analysis, the chill one, uses published numbers, quick and simple. So basically, pairwise equal 1v1 battle, network equal Royal Rumble, IPD equal data deep dive, and aggregate equal lazy Sunday meta-analysis. Next up, the scope of your adventure. A scoping meta-analysis. The explorer, broad topics, big picture. Systematic review and meta-analysis, the gold standard, organized, serious, and route. Cumulative meta-analysis, the time traveler, updates results with each new study. Living meta-analysis, the one that never sleeps, keeps updating as new research drops. They like comparing a trist map, a history book, a time-lapse video, and something like Google Map Live. Okay, now we're getting nerdy. These are the special purpose meta-analyses. Meta-regression, the detective, find what explains heterogeneity. Subgroup meta-analysis, breaks data into little gossip circles. Dose response meta-analysis, asks, does more dose mean more drama? DTA meta-analysis judges diagnostic tests, who's the most sensitive? Prognostic factor meta-analysis, predicts the future. Genetic association meta-analysis, play with SNPs and DNA. Survival data meta-analysis, tracks who outlasts who. Multivariate meta-analysis, multitasking queen, analyzes many outcomes at once. Component network meta-analysis, breaks complex treatments into parts, the Lego version of meta-analysis. This slide is basically the Avengers lineup meta-analysis. Everyone's got their own superpower. Umbrella Review, the big boss, combines results of many meta-analyses. Rapid meta-analysis, the speedster, used when decisions are needed yesterday. Mega-analysis, the data monster, merges raw data from all studies into one giant dataset, like microarray in genetic concept. So, umbrella equal big picture view, rapid equal caffeine-fueled sprint, mega equal data Godzilla. Who said stats can't be epic? And finally, the special editions. Prevalence meta-analysis tells us how common something is, like how many people hate Mondays. Correlation meta-analysis measures relationships, love stories between variables. Effect size meta-analysis, the classic one with OR, RR, HR, and SMD, pure power. Missing data meta-analysis, handle studies with hole in them. Network component meta-analysis analyzes treatment networks and the effects of each part. So yeah, meta-analysis isn't just one tool, it's a whole toolbox, a Swiss Army knife of science. And that's it. You just survived the jungle of meta-analysis. Congrats! Congrats! You're officially a data explorer. We went from effect sizes to random models, from heterogeneity to Bayesian brain melting magic. But before you go, there was a tiny little mistake hidden somewhere in this video. Did you catch it? Was it a number? A concept? Maybe the cute dog distracted you again? Write your guess in the comments. Let's see who's the real meta detective. And don't forget, subscribe before the heterogeneity hits 100%. See you in the next Meta Madness episode.